Let's have a look at some examples. So in all these, we're going to use the integration. So if we're starting with y, sorry, we're missing our pen there. Y is y dash is equal to x to the power of n. Then our primitive function was going to be x to the power of n plus 1 over n plus 1. So we add 1 to the power, and then we divide by the new power each time. Add 1 to the power, divide by the new power. And then we're going to add a constant each time. So let's have a look at the first one. We've got x cubed plus x. Now we're going to treat, because it's two separate terms, we integrate them separately. Okay, so we're going to integrate x to the power of 3. We're going to add 1 to the power, divide by the power. X to the power of 1 will become x to the power of 2, divide by the new power of 2. Add a constant. That's as simplified as you're going to write it. You could write it as a quarter of x to the power of 4 plus a half x to the power of 2 if you want, but not necessary. So just leave it like that. But keep reminding yourself to go to this rule. So the next one, we start with 3x. We're going to integrate that. So we're going to add 1 to the power, so it becomes squared, divide by the power. X squared becomes x cubed, and we divide by the new power of 3. Now 3, well, technically if you want to look at it, it's x to the power of 0 because it's a constant. So 3x to the power of 0. We add 1 to the power and divide by the power, which is 1. So remember, if we go the other way, we differentiate 3x, it becomes 3. So integrating 3 becomes 3x. So we can see the relationship between differentiation and integration in whichever way we're going. So if we have a look at the next one, 3x to the power of 5 becomes 3x to the power of 6 over 6. And then that can come down. We can just clean it up and divide the 3 into the 6 and give us 2. 4x to the power of 3 becomes 4x to the power of 4 over the 4, which is the new power. And again, it cleans up. The 4's cancel. X to the power of 2 becomes x to the power of 3 over 3. So we can see that that's just going to stay the same. And 6x becomes 6x squared. And divide by the new power, which is 2. And that just becomes 3x squared. So if you have a look, if you differentiate that at any stage, you should get back to that point. If you don't, then you've done something wrong, one way or the other. Working with negative indices is not a problem, but what we've got to do is make sure we don't make simple errors. We're going to add 1 to the power and divide by the new power. So minus 2 plus 1 is minus 1, and that's going to be divided by minus 1. Common errors I would see there is to put it as minus 3. And people start to subtract instead of add, which just makes it a little bit, well, it's going to get it wrong. So be really careful to make sure when you've got the negative powers that you're adding 1 and not subtracting 1. 4x to the power of 1 becomes 4x squared over 2, and then it cleans up. Same with part 1, the first one. It cleans up just minus x over 1, x to the power of minus 1. And 5x to the power of 3 becomes 5x to the power of 4 over 4, which doesn't change too much at all. We look at 5, 2x to the power of minus 3. Again, add 1 to the power becomes minus 2. And divide by the minus 2, which will just give you the minus x to the power of minus 2. 2x to the power of minus 2 becomes x to the power of minus 1 over the minus 1, which cleans up to minus 2x to the power of minus 1. And x to the power of 6 becomes x to the power of 7, and divide by the 7. And we get our constant of integration. X cubed becomes x to the power of 4 over 4. Add 1 to the power, divide by the power. 5x becomes 5x squared, and dividing by the 2 because that's the new power. And 4 becomes 4x plus a constant. One we haven't seen here, and we're not going to see it for a while, is this situation. When we got to try and integrate x to the power of minus 1, what if we try and do this by a normal means, we get x to the power of 0, but we have to divide by 0. Dun dun, that's undefined. We can't do that. So you've got to be really careful. That actually, and we'll do this later on, the integral of, when we integrate this one, it actually becomes the natural log of x. We'll do that in term 2, so don't panic about that one now, but you won't see it in these types of questions that we're doing here. If it is, well, then it's an error because we don't want to do it yet.